Okay, hi everyone. We are Triple J Design, and our design project is the food service glove applicator you can see here before you. I'm Jake Delgado,
I'm Josh McConnell.
And Jonathon Ouyang.
and this is the project that we would like to describe for you today. Okay, hi, we would like to demonstrate for you now our food service glove applicator. So here you can see the machine is ready to go. It's telling us to lift the lid to start the process. So I lift the lid here, take a food service glove and install it on the machine like this. Then close the lid, and the machine says to press down the handle and hold. And when I press down the handle, it starts a vacuum pump that grabs the glove, and after it counts, it says to release the handle. And when I release the handle, it pulls the glove open. Then it says that we can insert the hand and press a pad in the middle of the screen here, and I can't fit my hand in there, but when I press the pad up here, it shuts off the fan, and then it says to lift the lid and remove the hand. So I lift the lid, and then I can remove my hand with the glove installed. And when I close the lid again, it's ready to start the process all over. And you can see inside here our electronics. This is the pressure pad that turns off the vacuum motor and blower. The vacuum motor is there. The blower is back here, kind of out of view. Our central microprocessor is there. And then this device over here is the motor controller that sends power to the motors when the microcontroller instructs it to turn them on. And that is our project. Thank you very much for looking.
Hello, I now like to talk about our mechanical design. This is our exploded assembly of our food service glove applicator. There are 5 main parts, which is the top lid, the bottom, which includes an integrated vacuum port, the fan duct, the top vacuum platform, and the handles. All of this was 3D printed using PLA, except the handles, which is made out of wood. Connected to the handles are torsion springs and bushings to space the handle, arms, and where it is connected to, as you can see right here. We have cutouts for the screen, the fan, the air holes, which are in the back, the sensor buttons, which is 2 right here, and the power supply, which is in the back. And we also have a cutout on the bottom and the top for the acrylic plates. We used acrylic plates, which was 1 on the bottom and 2 on the top to sandwich the sensor, as Jake showed earlier, and this dispersed the force of when the person is tapping the sensor. As you cannot see the paths for the vacuum for the top plate and the bottom plate, I will show you that in SOLIDWORKS right now. So hello and welcome to SOLIDWORKS. So as you can see here, we have 2 slots for the O-rings, and right here you can see our vacuum port. So we have 1 channel leading to both ports, which lead to an exit where you can attach the hose. Now this is the bottom half cutout for the vacuum plate, and I split this in half so again you can see it, and it's the same exact concept as the top vacuum plate, except it is integrated into the bottom. So this is the right side, and with the left side is the same concept. So again, it leads into 1 channel to both ports, and as you can see right here, I made a cutout for the screen to make it fit better. So thank you very much.
Hello, I'd like to talk to you now about the electrical system for our project. This is a 5-volt base system, so this 5-volt power supply sends power to this power block, which routes power to the microcontroller, a Raspberry Pi Pico, and this dual H-bridge motor driver. The motor driver supplies power to the vacuum pump and blower motor, which require more current than can be delivered by the Pico. So at the beginning of the process, the display here shows a message to lift the lid and insert a glove. When the lid is lifted, this lid position sensor sends a signal to the Pico that the lid has been lifted, the glove is inserted, and then the lid position sensor again sends a signal to the Pico that the lid is now closed. At that point, the display sends a message for the user to press down on the handle on the lid. When the handle is fully depressed, the handle position sensor here sends a signal to the Pico that the handle is down. At that point, the vacuum pump is activated and a message is displayed on the display to hold the handle down while a 4-second vacuum building time period elapses. At the end of that period, the user is instructed again by the display to release the handle, and at that point the blower motor is activated and air is blown into the glove to inflate the glove. When the motor is activated and the air is blowing in, the display then changes to read insert hand into the glove and press down on the sensor area on the top of the base of the device, and that pressure sensor is located on the clear plastic cover over the base. When the user presses down on the pressure sensor, a signal is sent to the Pico that pressure has been applied, and the Pico then turns off the vacuum pump and the blower motor and sends a message via the display to the user to open the lid and remove the gloved hand. Once that is done and the lid is closed again, the lid position sensor sends a signal to the Pico that it is closed again, and it resets to the original message, which is to open lid and insert a glove. And that is the electrical system for our device. Thank you for watching.
For the logic of our machine, we decided to write a program similar to a state machine. One major difference in our machine is the use of only one program. In a typical state machine, a main program with the states and an inventor program are used. Our machine only uses one program to keep track of the current state using a single variable and continuously checks for event conditions to be met with if statements. One benefit of using a state machine is the transition between states being independent of time. This is useful for our machine as actions like placing a glove and removing it will depend on the user, allowing the entire process to take as much or as little time as required. Although independent of time, one state in our program does require a amount of time to elapse under certain conditions. Using the same principles as the state machine, this timer uses a single variable to track predetermined timer intervals in order to update the LCD screen, all while being able to continuously check if the correct event conditions are being met. Once a cycle is completed, the program will automatically return to the start, ready for the next glove application.
Our project is a food service glove applicator, and the idea is to have a machine that will install the glove on a person's hand who's got a wet hand and it's hard to get the gloves on. So the intent here is for the machine to hold the glove open, and then you can put your hand in, and then after you press the sensor to tell it that the hand has got the glove on, then it lets go of the glove, turns off the vacuum, and then you're done.
What's your name?
My name is Jake Delgado.
My name is Jonathon Ouyang.
And I'm Josh McConnell.
Nice. Okay, so do you want to run it to show?
We can run it, but we ran into an issue, and that is that our motors are not strong enough to actually serve the purpose.
Okay.
Everything runs the way it's supposed to. The
Okay.
motors come on when they're supposed to.
Okay.
It responds to the prompts, but it doesn't create enough vacuum
Okay.
to hold the glove open.
But can you show something or no?
Yeah, for sure.
Okay.
See, right now it's saying lift lid to start. So what you're supposed to do, would you hand me a glove out of there? I mean, we can show you putting the glove in and kind of what the idea is. The problem is it just won't lift. It just doesn't create enough suction.
Oh, I see.
So this is, the kind of glove that we put in here. So you lift up the lid and then you put the glove on here. And then the idea is to line it up with these vacuum ports at the end. And then close the lid, and then it says to push handle down and hold. And at that point, it turns on the vacuum pump.
So you make vacuum where?
Uh, the vacuum is being pulled through these lines and into the ports, two on the top and two on the bottom.
So by making vacuum, how we can?
So it's supposed to grab hold of this thin glove and then pull it open. And then once it's got a grip on the glove, the air that's blowing right now but not strong enough.
Oh, it would get the bottom layer.
Yeah, and there's another pair up here.
Oh, got it. Okay, so you have two vacuum, and when you open it up,
Then, right.
Blow
This-
like a stream of air.
See,
to
ideally,
inflate
it would be gripping it
oh, got it,
like this.
got it, got it. Got
And
it.
then the air that's coming out of here right now would blow the glove open.
So
it
they're trying to make vacuum.
Right,
Yes.
and that's the pump you hear right now.
And what are the other? What's
And
the other
then
thing?
once you stick your hand in here, then you press down here. And it
Do you know what happened? I think you lifted the lid. So there's the way we coded it is that if you ever lift the lid at any point in time, it resets.
Okay, can you do that again?
It-
You can turn it around to be more comfortable.
Okay,
Yeah.
so, again, we've put the glove in, now it's saying to push handle down and hold, so you push it down and hold it. Then it has a count,
To make
And
sure you
then-
feel the
Okay.
you release the handle, and then insert the hand, why don't you put it in?
picture, yeah.
there?
And then you just go in and then you press down on here once it's ready. Is it not reading?
I don't know why,
Let's do this again.
yeah, for some reason the sensor is not sensing the pressure
Mhm.
right now. When we tested it
Or we
last
can-
night, it was working fine.
You can put more pressure, doesn't it?
Yeah. Well, usually it doesn't take that much. I mean, when
Yeah.
you press it down, and I'm not sure, okay, so,
And just reset it.
Yeah, just unplug it.
You can measure the sensor values.
No, yeah. So we actually used the ADC, the analog.
I know,
channel.
but right now you can first see what are you reading for the sensor.
Usually it reads 0 when there's nothing on it.
yeah.
No, when there is something on it, they
Oh,
have
when
to
it-
see that what are you reading
Yeah.
in
so
your
it-
code.
In the code, well, there's a threshold that I set, or yeah, that we set, and it waits for it to read up to 50,000.
I was just looking to see if maybe it's become attached here or something.
Or these sensors may, they say after a while, the values will be different. It depends what's the threshold that you put, for.
Yeah.
Yeah. Well, it's definitely
Can
more,
I see inside? So
Oh,
these are your
of
vacuum.
course. yeah.
This is your
So
vacuum.
the vacuum pump is right there, and then it runs one up here and then another one up to the lid here. And then the blower is right there, and it blows through here and then it comes out there.
Oh, the blows would come from where? Here.
Yeah, the blowing air comes out of this slot and it blows into the
Can-
glove from the back.
Okay, we can feel the blow at least.
Oh, yeah. So, again, it says now push down handle and hold. Right now it's pumping the air. Then when we release it, then it should be blowing air. And then you insert your
Yeah.
hand and then
Okay.
press down on here.
And have you 3D printed all of the parts?
Yes.
Yeah, except for the handles. I don't know
Okay.
why this is suddenly not reading though, because it's been working fine up until now, and it doesn't take that much pressure.
Okay. So you have to then take another video when the system is working, like at least the pressure is working, pressure sensor.
Okay.
Okay.
Okay,
Because I could feel that, yeah, the vacuum pump is working, but it's not strong enough.
Yeah.
right.
But you
right.
can probably you need to run the code to see what are you reading for pressure, and then adjust it. Or if the sensor is not working, you can get something else.
Yeah, we may have to replace the
Yeah.
sensor, but it's strange because it's always been pretty sensitive.
Okay, sounds good. You can check it later because we don't have time. If you want to check it right now, that's okay. You can do that somewhere here, and let me know if the sensor is working.
Okay, so do we need to do this video again, or are we talking
You have
about for
to
the
you have to
present-
submit a video, yeah, presentation.
Yeah,
In that, if that is working, that's fine. Also today, if you can fix it, you can let me know.
okay.
Okay? Okay,